This small demo captures everything that was presented in the last few slides. So we have all the normal stuff up on top that we don't need to go through anymore, and the usual stuff down here. So here's where the code of interest occurs. What this demo does is it creates a new pane and drops a single letter, the letter A, as a string, as a piece of text, into that pane at coordinates 2020. And of course, here's how it adds it to the pane. And then we are going to be using the up, down, left, and right arrow keys to move that A around within the pane. We're going to be using the set on key pressed method to deal with this. So we're going to create a listener or handler for this so that when our text is focused and someone hits a key, and notice we're using the lambda notation to specify the listener here. So this says, okay, I'm using lambda notation to set up an event handler, and here is the code for my event handler starting at that curly parentheses and ending at this. And then notice that the normal way we would do this is we would say text dot set on key pressed bracket, and then we would have the name of a handler and a closing bracket. So what we're doing with the lambda notation is we're throwing all the stuff that would normally be somewhere else and referred to by a name, basically making an anonymous inner class piece of code out of it and using lambda notation to indicate that we're doing that. So here's the actual event handler right here. Now what does it do? Well, we're only here because someone pressed a key. That means it's appropriate to take the event object and to invoke the getCode method to see which key was pressed. That is functioning as the control variable for a switch case statement, and now we check all the different cases that it might be using the constants that you were shown earlier in that table. So we check it against the constant down and see if it's equal to the down constant. If it's not, we move on to this case and check to see if it's an up. If not, we check to see it's a left. Notice, of course, there are breaks after every case, so we never fall through. And if we get to the right case and it still isn't true, then of course we're going to do the default case, which is specified right here. Now the default case is to simply check to see if the length of the text is greater than 0, and if it is, then we're going to set the text equal to that new piece of text. Now just to clarify here, there's two different pieces of text involved. There's the text that's in the window and the text that comes from the key pressed event, and we're setting the former to the latter. So right here we set the text, that is the piece of text sitting in the window, equal to the text that's returned from the event object. So in other words, we'll get into this piece of code right here if something's pushed on the keyboard that has a length greater than 0. In other words, something like another letter, for example. Now do pay attention to what happens right here though. We do a text dot request focus, and you remember learning about that on the slides just a bit ago, that you have to have an object focused in order for it to be able to capture a key event. You also have to request the focus after you've shown the stage. So notice we show the stage first, we display the stage, and then this just sets up our event handler, and then the last line of code is actually to request focus before we run out of code. So let's try the demo and see what this looks like. So there we get it. We get a small window with an A in it located at coordinates 2020. Now if I push the right arrow, this will happen. If I push the down arrow, this will happen. Left arrow, this happens. And up arrow, this happens. You'll notice I can actually go to negative positions. If I was to push the up arrow 5 times, and then the left arrow 5 times, then the down arrow 5 times, and then the right arrow 5 times, then you can see finally it comes back into view. So it actually took a little trip here. It went up and around and down and over and back into view again. The same happens on the other side of the window, of course. So for example, let me just make the window a little bit smaller. So if we were to now move over to the bottom right corner, and then let's go 5 down, 1 2 3 4 5, and 5 more to the right, 1 2 3 4 5, and then if I resize the window, you'll find that the letter has actually moved over to there. Now what if I push a different key other than arrows like I'm pushing now? So if I was to push a capital B, let's say, well, it doesn't matter that it's shifted, which is interesting. And why? Because I'm not checking for shift up or shift down. I'm just checking for the actual keys. So here you can see I'm typing a number of lowercase letters. Here I'm going to put the shift key on, and capital letters don't make any difference. It still comes out as lowercase, again, because I'm not acting on recognizing whether or not the shift key is being pushed as well. If I push something like the escape key, you can see nothing happens. But if I push a number or anything that actually has a visible code associated with it, then I'm going to see that letter come onto the screen. Of course, when I go back to pushing up the arrows again, the new piece of text simply moves around. So that completes this particular demo.